All right, so this is how you do question 11 for homework 8. So first, you want to start with this part of the circuit as you're given a battery source here. And so automatically your attention kind of focuses at that point because you can solve using the battery source. So initially what you want to do is solve for V1. Now, you can do this because you know that for op amps, IN equals IP equals 0. So the current here is 0. So the NVM for this is really simple. It's just 12 minus V1, which is this voltage, over 40, because like this current in, minus V1 over 20, this current out, is equal to 0, as there's no current over here. And so using that, you can just solve for V1 is equal to 4 volts. Now, just a quick look at this, you know that this is VP. So VP is equal to 4 volts, so VN on this side is equal to 4 volts. Now, this is the tricky part of the problem, in my opinion at least, and is what I got stuck on. At first, I tried to do NVM for the current going in. However, IP is equal to IN is equal to 0, and this is IN on this side. So the current here is just 0, so there's no voltage drop off across this resistor, even though there is that resistor. So this node actually has a voltage of 4 volts. Now, after realizing this, the problem becomes pretty simple. So just a quick analysis of the circuit. So VP is equal to VN, so you know that this voltage and this voltage is the same, and we'll name that this V3, and we'll name this node, the voltage at this node, V2. And so doing this, you can set up a system of linear equations to solve for V3, which, since this is a supernode here, is just equal to V0. So in order to do this, the first node that you want to do NVM at is this specific node. And so you can do IN minus the current going through this minus the current going through this is equal to 0. And so that will look like this. So IN minus 4 volts, because that's the voltage at this node, minus V2 over 20 minus 4, again, the voltage at this node, minus V3 over 20 is equal to 0. And so IN, again, just equals 0. So that's your first equation. And so this only has 2 different variables, so you only need 2 equations to solve for both of them. So the second equation that you need to solve for V2 and V3 is you can look at the NVM for this specific node. Now, at first you might be tempted to do this node or this node, but there's this I term here for these 2 nodes. Again, this is super node, so it goes to here. There's this I term, and so that adds a third variable, so you need a third equation to solve for it. And you can't create that third equation given the circuit that you have. So you want to look at NVM for this node. Now, the NVM for this node is just the current going in through here is equal to the current going out to the op amp and the current going down here. Now again, this current is just 0 because IP equals IN equals 0. So given that, you can set up this equation where V2 minus V3 over 20, the current going into this node, minus V3 over 40, the current going out because there's no current going this way, is equal to 0. Now, given these 2 equations, this one and this one, I just put them into a linear solver. And so I got that this should say V2, is equal to negative 24 over 5. And V2 is equal to negative 16 over 5, which is equal to negative 3.2. Now, just looking at this, as I said, this was a supernode. So the voltage drop off across here is V0, right? And so the voltage drop off from V3 down here, which is V0, is so the voltage at this specific node is equal to the voltage at the V0 term that you're looking for. And since this is a supernode, the solution for V3 is equal to V0. So negative 3.2 volts is equal to V0. Thank you.